So in this video, I'll be going over the derivation of the moment of inertia of a solid disk through its center. I'll be starting out with the common formulation of the moment of inertia, that being the integral of r squared dm, where the small r is the distance away from the axis of rotation you are, and dm is your small mass element. So in the top left corner, I've shown an aerial image of the disk. So I've given a radius of capital R, and to the right of that, I've shown a side view of the disk with its axis of rotation through its center. In this video, I've given it a little thickness to be able to better visualize what's going on, but I'll be doing the derivation in 2 dimensions. However, you actually get the same result in 3D, which is why the moment of inertia of a solid disk is the same as that of a cylinder. But to actually start the derivation, a common first step in these derivations is to change your mass element into something more related to distance or length. So we can change dm into sigma dA, where sigma is areal density, meaning mass over area, which in this case is mass over pi capital R squared, because our solid disk is a circle. So from that step, what we can do is we still can't actually evaluate that integral, or it would be tricky. But to make it easier, we can change our small area element into something directly related to the distance away we are from the axis of rotation in changing dA into 2 pi r dr. So I've chosen my infinitesimal area element to be a infinitesimally thick ring about the axis of rotation. So the area of this ring is 2 pi r, the circumference, times dr, its infinitesimal thickness. From that step, we can rearrange terms and actually put bounds on our integral. So we're integrating from 0 to capital R, meaning from the axis of rotation at 0 to the full radius at capital R. Performing this integral, you'll get 2 pi sigma times r to the 4 over 4, evaluated from 0 to capital R. And just plugging in the values, you get 2 over 4 pi sigma times r to the 4. From this step, with some foresight, we'll rearrange terms. You can get this into 1/2 times sigma pi r squared times another r squared, so we split up the r to the 4th. And you'll notice here that pi r squared is the area of our disk, and once you get into this form of 1/2 sigma a times r squared, you'll notice that we've defined sigma to be our areal density, so mass over area, and in that way sigma times A is our mass. So from that step, you can get to the final result that the moment of inertia of a solid disk through its center is 1/2 mr squared. So I hope that you enjoyed this video, and thank you for watching.